Hello, very good morning to you. Yeah, yesterday we discussed about the potential well. So that is the subsequent topic of the potential well is when E is greater than V. We discussed in the yesterday's class. So in this class we are going to discuss about a potential well. So next topic, when E is less than V. When E is less than V, this condition belongs to the which one it is bound state, because so many times your competitive people are asking the questions based on the bound state. So this is very important topic. You have to utilize this chance and be practice, because this class is very important to you. So once again I am requesting you over there in the physics field preparing the competitive examination, you have to inform them. So like this nowhere you will get it the content. So topic by topic no one can teach to you. Once you have to our app download, and then you have to see how depth we teach, how much syllabus we covered. So if we finish the topics you have to see, right, and you decide, and then you able to take the app also, you purchase it. It will help you to enhance your knowledge, right. So now we are going to discuss about the potential well under the bound state conditions. So when E is greater than V, we discussed in the first case we are discussing the E is greater than V. Now we are going to discuss about the E is less than V. We are going to discuss which one we are going to discuss. E is less than V. Already we are discussing about the E is greater than V. We are discussing. Today we are going to discuss about E is less than V. E is less than V we are going to discuss. Clear? So this is the less than. E is less than V we are going to discuss. This state we call it as a bound state. Which one we are going to write? It is bound state. It is very important in the quantum mechanics. Bound states are very important. Our particle is bounded in the particular region. Such type of state we call it as a bound state. We have to write. What is the definition of the bound state? Once you have to see, if the motion of the particle is, the definition of the bound state is, if the motion of the particle is confined to a limited region, if the motion of the particle is confined to a limited region of space by the potential energy, the motion of the particle is confined to a limited region of space by the potential energy, to that particle can move back and forth in that particular region, then so that particle is said to be in the bound state. That particle is said to be in the bound state. What is the bound state? Once again you have to see, if the motion of the particle is confined to a limited region of space, if the motion of a particle, if the motion of the particle is confined to a limited region of space, limited region of space, if the motion of a particle is confined to a limited region of space by the potential energy, if the motion of the particle is confined to a limited region of space by the potential energy, to that the particle can move back and forth, the particle can move back and forth, the particle can move back and forth, the particle can move back and forth in the region, then the particle is said to be bound state. The particle can move back and forth, the particle can move back and forth in that region, the particle is said to be, which state it is? Bound state. That particle is said to be bound state. Now I have to draw the diagram. So how it will be? Bound state is existing. Once you have to take. In yesterday we discussed about the potential well. The same potential well I have to take here. Here how many regions are there? Here 3 regions are there. This is the region number 1. This one you have to take it as a region number 2. This one you have to consider as a region number 3. 3 regions are there. Here wave function you have to take it as a wave function is I1. Here the wave function is I2. Here wave function you able to take that wave function is psi3 wave function is there. according to our condition, the energy of the particle is less than the potential energy. The energy of the particle is less than the potential energy. Maybe you have to take this is the energy of the particle you have to consider. This energy of the particle is less than the potential energy. What is the potential? Well, height is equal to minus V naught height is there. So, the potential well height is equal to how much height is there? Minus V naught height is there. Here you have to consider here. So, what you are going to take here your potential well you able to take how we have to define. This is x is equal to minus a, this one you have to take it as a, x is equal to plus a, this is the width of the potential well. Here the energy means that is the kinetic energy of the particle. So, that energy is going to take it as a negative here, right. So, here you able to take that energy you are going to take it as a positive. So, that energy you are going to take it as a positive because here the potential energy is equal to 0. In the region the particle is freely moving to and fro motion, that is why the potential energy is equal to 0. Here the energy of the particle is equal to negative, it will come, the energy of the particle is become as a negative. How we have to define the potential? So, in everywhere the bound state condition of the potential is equal to, what is the bound state condition of the potential is equal to the potential V. So, here you have to consider as a V, the potential height you able to take it as a, how much you have to consider V. Here also you have to consider the potential is equal to plus V, you have to consider here the potential is equal to V. So, when it is V, the potential is equal to V when x is less than minus a. The potential is equal to 0 when it will be 0, minus a is less than or equal to x is less than or equal to plus a, the potential is equal to 0. Again you have to take the potential is equal to V when it will be z, when x is greater than a, the potential is equal to V. Such type of thing you have to take it as, this is the condition for whom, this is the condition for the bound state condition you have to take. Now, in the three regions we are discussing all these things, right. This is the last case in eigenvalue problem, the potential well under the bound states, clear. When E is less than, this is the less than, when E is less than, V potential energy. Now, you have to write it is. So, in region 1 we have to apply the, so in region 1 we need to apply. So, what is in the region 1? In the region 1 our potential energy is equal to how much you have to concentrate. In the region 1 our potential energy is equal to V. So, that V is equal to V only, this is the potential energy in the region 1. Now, you have to apply the Schrodinger wave equation. So, dou square psi 1 is divided by dou x square plus 2m into E minus V is divided by h cut square into psi 1 is equal to 0 according to your, this is the Schrodinger wave equation. But our condition is E is less than, what is our condition? Our condition is E is less than V. Our condition is E is less than V. If E is less than V, you have to apply here, what is going to happen? Here E is greater than V is there. That is why you have to rearrange that expression. Dou square psi 1 is divided by dou x square minus 2m into V minus E is divided by h cut square into psi 1 which is equal to 0. So, what is this? This is very, very important expression we are going to take. Dou square psi 1 is divided by dou x square minus 2m into V minus E is divided by h cut square into psi 1 is equal to 0. This is the condition for E is less than V. So, based on this we have to write it, you have to take this entire this constant, you able to take it as a, which one you have to consider, that is the k1 square, you have to take this entire thing. So, therefore, k1 square is equal to what we have to write here, k1 square is equal to 2m into v minus e is divided by h cut square. This is the k1 square. So, therefore, you have to substitute there. What is going to happen? Dou square psi 1 is divided by dou x square minus k1 square into psi 1 is equal to 0. This is the second order differential equation. If you have to solve this differential equation, you able to get the wave function, that is the psi 1 is equal to a e to the power of I. So, a e to the power of k1 into x plus b e to the power of minus k1 into x. This is the exponential function we are going to get. So, from this function, which one is executing, which is not executing? So, we have to discuss about this. First, you able to see here I am writing for a negative x axis, what we have to write here once you have to see, for negative x axis, b must be 0. For negative x axis, what we have to write it is b, your constant b must be 0. For a negative x axis, b must be 0. Why it will be b must be 0? Suppose if you have to take, so b must be 0. Psi of x tends to 0 when psi of x tends to 0 when x tends to infinite. Psi of x tends to 0 when x tends to infinite, so that is why b must be 0. Therefore, what we have to write it is a is not equal to 0. Therefore, what is it telling? A is not equal to 0. Why a is not equal to 0? Psi of x tends to infinite when x tends to infinite. Psi of x tends to infinite when x tends to infinite. So, that is why you have to consider a term, you have to consider, and b term is unnecessary term. Which one it is? Unnecessary. Unnecessary term. This term is unnecessary term or unacceptable term. This term is unacceptable term. So, therefore, our wave function you have to take it as psi 1 of x is equal to a e to the power of k1 into x. This is the wave function you have to take. Which wave function? A e to the power of k1 into x you have to take, while we have to use the unnecessary condition. Clear? This one you able to take that equation you have to remember. After some time I have to use this equation. In the region 2 you able to see, first you have to observe the potential energy. Our particle is moving back and forth. So, that is why the potential energy is equal to 0 in the region 2. Our potential energy is equal to 0 because the kinetic energy is positive, the energy of the particle is positive. Once you have to apply the Schrodinger wave equation in region 2, dou square psi 2 by dou x square plus 2m into e minus v, e minus 0 is divided by h cut square into psi 2 is equal to 0. Clear? So, therefore, what we have to write it is dou square psi 2 is divided by dou x square plus 2m is divided by h cut square into psi 2 is going to take it as a 0. Here this term you able to take it as a constant, that a constant is k2 square you have to take, where k2 square is equal to 2m is divided by h cut square. This is the k2 square value. Now, you have to substitute the k2 square value here. So, how much you able to get? Dou square psi 2 is divided by dou x square plus k2 square into psi 2 is equal to 0. Now, you have to solve this expression. You able to get the wave function psi 2. Psi 2 is equal to some c e to the power of I k2 into x plus d e to the power of minus I k2 into x. This expression we also write it as, therefore, Another form also we able to take C sin k2 into x plus d cos k2 into x also we have to write. It is, this is a sinusoidal particle will come in the bound state, clear. So, C sin k2 into x plus d cos k2 into x, we are getting this entire thing is existing in the region 2. Now, we have to apply the Schrodinger wave equation in the region 3. In the region 3, what is that? The potential energy is equal to V. So, V is equal to, here in the region 3 is potential energy is existing. Now, you have to take the Schrodinger wave equation, dou square psi 3 is divided by dou x square plus 2m into E minus V is divided by h cut square into psi 3 is equal to 0. This is the Schrodinger wave equation, but according to our condition E is less than, what is our condition? E is less than V is our condition. So, therefore, according to this condition, this term is not suited, that is why we have to rearrange that term. So, dou square psi 3 is divided by dou x square minus 2m into V minus E is divided by h cut square into psi 3, which is going to take it as a 0. This is the wave expression you are going to get, clear. This is very, very important. Already we know that this term, what term it is, this is the k1 square. Already we previously we assumed 2m into V minus E is divided by h cut square, that is the k1 square value. Now, you have to substitute in that differential equation, what you are going to get? Dou square psi 3 is divided by dou x square minus k1 square into psi 3 is equal to 0. Here you have to take the psi 3 is equal to some f into e to the power of k1x plus g into e to the power of minus k1x, we are going to get it, g into e to the power of minus k1 into x. So, in this expression some unacceptable term is existing for here. So, what we have to write it is for positive, what we are taking for positive x axis, here positive x axis you able to consider. For positive x axis, here we have to take, for positive x axis f must be equal to 0. For a positive x axis f must be equal to 0, f must be equal to 0. Why it is f must be equal to 0? Psi of x tends to 0 as x tends to infinite. Psi of x tends to 0, as x tends to infinite. So, f must be 0, you have to take it as psi of x tends to 0 as x tends to infinite. Psi of x tends to is not equal to 0 as x tends to infinite. So, that is why it is going to take it as a f, you have to take it as a 0. Why you able to take it is not equal to 0? G is not equal to 0. Here G is not equal to 0 when, so why it is G is not equal to 0? When psi of x tends to 0, as x tends to infinite. So, therefore, which term is unnecessary? Here unnecessary term is f into e to the power of k1x is unnecessary term. Which term it is? This is a unnecessary or unacceptable term. Unacceptable term is in the region 3, f into e to the power of k1 into x is equal to 0. So, therefore, our wave function psi 3 is equal to g e to the power of k1 into x, we are going to get g e to the power of k1 into x, we are going to get it. So, from this what we have to write here, in the region 2 you able to take in the region 2. So, there are two wave functions are there in the region 2. In the region 2 there are two wave functions are there. So, what are those two wave functions? psi 2 of x is equal to, we know that c into sin k2 into x plus d into cos k2 into x in the region 2, two wave functions are there. One is a sine wave function, that function is anti-symmetric function. Already you know that sine wave function, that function is anti-symmetric function. What is the definition of the anti-symmetric function? F of minus x is equal to minus f of x, this is the anti-symmetric function. If that you have to take it as a, the second function is symmetric function, that symmetric function is cos function, there f of minus x is equal to f of x, you have to take this function, we are going to write it as a cos function, we have to write. Here two wave functions are there, there are two wave functions, one is psi 2 of x is equal to c sin k2x plus d cos k2x, these are two wave functions are there. The sine function we able to take it as a anti-symmetric function, the cos function we have to write it as a symmetric function is there. So there will be two distinct set of solutions, here two wave functions are there, that's why we have to write it as two distinct set of solutions also existing in that. How we have to exist, you able to write it is two distinct set of solutions, how we able to take, once you have to write, you able to take that bound state condition, once again you have to write it is. So what is the bound state condition you able to take? When E is less than B, when E is less than B, you have to take your first boundary condition x is equal to minus a, the second boundary condition x is equal to plus a, here the potential energy is V, here potential energy is equal to 0, here you have to take the energy is, you have to consider as a negative, here energy you able to take it as a negative, here energy you have to take it as a positive, you able to take. Now here you have to take it as the wave function, that psi 1 is equal to, what we have to write it is psi 1 is equal to a e to the power of k1x, here the wave function is there, what is psi 2? Psi 2 is equal to c sin k2x plus d cos, so k2x we have to write it. Here psi 3 is there, psi 3 is equal to, what is the psi 3? g e to the power of minus k1x, this is the psi 3 value. Now here two distinct set of solutions are there. For one set of solution we have to write it is, for anti-symmetric, one set of solution is anti-symmetric solution we are writing, anti-symmetric solution, two distinct set of solutions are there, anti-symmetric set I have to take. So what is the anti-symmetric set of solutions? Anti-symmetric set of solutions you able to consider. So what is that? Psi 1 is existing, so the first term is psi 1 is existing, psi 1 is equal to a e to the power of k1x, so psi 2 is equal to, what we have to write the psi 2, that anti-symmetric function is c sin k2 into x, c sin k2x, this is the anti-symmetric function under the region 2. Psi 3 is there, that is g e to the power of minus k1x, this is the first set of solution for anti-symmetric set of solution. Now one more solution you have to take, so what is that solution? Symmetric set of solutions we need to consider, symmetric set of solutions you have to take. So what are the symmetric set of solutions? You have to identify the wave function psi 1 is equal to a e to the power of k1x, this is the first wave function. Now in the psi 2, what is the symmetric wave function? That is d cos k2x, that is the d in the region 2, you have to write it is, this is the symmetric wave function. Psi 3 is obviously existing, so therefore you have to take g e to the power of minus k1x, these are the two set of solutions we able to get it. not one set of solution, two set of solutions we are getting. Clear? Once again I have to draw the diagram. Once you have to see here how we able to draw the diagram. Here this is a bound state. From this bound state what we have to write it is, here the psi 1 is equal to our wave function e to the power of k1x is existing. Here the two wave functions are existing. Psi 2 is equal to c sin k2 into x plus d cos k2 into x is existing, cos k2 into x. Now here d e to the power of, this is the psi 3 wave function which is equal to minus k1 into x is existing. Now you have to write it is, here the first one set of wave function you able to take, this is one set of wave function. Here this is anti-symmetric function, that is why this wave function we call it as a anti-symmetric wave function, anti-symmetric set of functions, anti-symmetric set of solutions, anti-symmetric set of solutions, this is the first one. So what are the anti-symmetric set of solutions? Psi 1 is equal to a e to the power of k1x plus c sin k2x plus d e to the power of minus k1x. Now one more set of solution is there. So what is that one more set of solution you have to see? The one more set of solution is this solution you have to take it as a one more set of solution. Clear? So this solution you have to consider as a one more set of solution. Another set of solution is this red color solution you have to take. Which function it is? This function is a symmetric. So that's why this solution we have to take it as a symmetric set of solutions we are writing. Symmetric set of solutions. One more set of solution is we have to write it is that set of solution we able to take it as a symmetric set of solution. Anti-symmetric set of solution and symmetric set of solutions, these two varieties of the solutions we have to write. Now already we discussed in the first class itself, and whenever I taught the one dimensional box, that time I am giving, so what I am giving, the boundary condition for the bound states. So once again I have to teach to you. So what are the boundary conditions for the bound state? You know that if psi is a continuous wave function, if psi is, what is the psi? Psi is the continuous wave function. Your psi is a continuous wave function, you have to write it is. If psi is a continuous wave function, if you have to consider the psi is a continuous wave function, the first derivative of, so therefore what is going to happen? Dou psi by dou x is also continuous wave function. Dou psi by dou x is also continuous wave function. If psi is a continuous wave function, dou psi by dou x is also continuous wave function. If it is psi is a continuous wave function, dou psi by dou x is also continuous wave function. If dou psi by dou x is also continuous wave function, what is going to happen? Your natural logarithm of psi, your natural logarithm of psi is also continuous wave function. Your natural logarithm of psi is also continuous wave function, right? Your natural logarithm of psi is also continuous wave function. So therefore if psi is continuous wave function, your natural logarithm of psi also continuous wave function. So therefore the differentiation of natural logarithm 1 by psi into dou psi by dou x is also continuous, is also, what we have to write it is also continuous wave function. So this is the boundary condition for so bound state. What is the boundary condition for bound state? So 1 by psi into dou psi by dou x is a continuous wave function under the boundary condition. This is very important. Now each and every set we have to observe this boundary condition. For symmetric bound states you have to apply. For a symmetric bound states, what are the set of solutions? The set of solutions are psi 1 is equal to a e to the power of k1x, psi 2 is equal to d e to the d cos k2x, psi 3 is equal to, what is your psi 3? G e to the power of minus k2x. So, these are the set of solutions for symmetric bound states. For a symmetric bound states, what are the set of solutions? The set of solutions are this one. So, these are the equations for the symmetric bound states. But you know that according to the boundary condition, now you have to apply the boundary condition, you have to apply. Where we have to apply the boundary condition? How many boundaries are existing in the potential bound state? So, the boundary conditions at x is equal to minus a. Here two boundaries are there. The first you have to apply at x is equal to minus a. What is that boundary condition at x is equal to minus a? Once you have to see this boundary at x is equal to minus a, this is x is equal to minus a, x is equal to plus a. Here two boundaries are there. Here the wave function is psi 1, here the wave function is psi 2, here the wave function is psi 3 in the three regions. Now you have to apply the boundary condition for a bound state boundary condition 1 by psi 1 into dou psi 1 by dou x is equal to 1 by psi 2 into dou psi 2 by dou x at x is equal to what we have to write minus a, at x is equal to minus a. This is the boundary condition you have to write. So, now first you able to take 1 by psi 1. 1 by psi 1 is equal to 1 by a e to the power of k1x into the first derivative of, so 1 by a e to the power of k1x. After some time I have to apply that minus a. So, first you have to write the derivation you able to take. So, d into dou psi 1 by dou x cos theta you have to differentiate minus sin, so k2 into x. Again you have to write it is k2 is there. So, minus d, which one we have to write it is minus d. So, though psi 1, sorry, so though psi not psi 2, psi 1 only you have to take here. So, psi 1 is equal to, though psi 1 is equal to what we have to write it is though psi 1, that is a into e to the power of k1 into x into k1. Clear? So, we have to write it is, this is the, so derivation you have to after some time I have to apply x is equal to minus e, which is equal to 1 by psi 2. What is your 1 by psi 2? 1 by d into cos k2 into x. This is the psi 2 value. You have to differentiate what you are going to get it minus d into sin k2 into x. Again you have to differentiate, you able to get it as a k2 also you have to get it. Clear? So, now you cancel the terms a you have to cancel it, e to the power of k1x, e to the power of k1x you cancel, d you have to cancel it, sin theta by cos theta is equal to tan theta it will come. Here what is there? K1. K1 is equal to which one we have to write it is you able to take. So, once again you have to apply the limit. So, what is going to happen? The left hand side is k1 is there, k1 is equal to minus d into sin k2 into x. We need to apply x is equal to minus a. So, therefore, k1 is equal to minus d into sin of minus theta is equal to minus sin k2a is divided by cos k2a, sin k2x is divided by cos k2x. So, that is the cos k2x you have to write it is, so sin cos we have to take it as a cos k2a is there. So, therefore, minus into minus plus is there. So, which one? D already is get cancelled, here also d is there, d get cancelled here. So, minus into minus plus is there. So, therefore, k1 is equal to tan, which one it is, k2 also is there here, k2, here also you have to take it as a k2 is there, you keep the k2 is there, k tan, so k2a, so tan k2a into 1 k2 you have to keep. So, this expression you have to multiply with both side a, you have to multiply k1 into a is equal to k2 into a into tan of k2 into a. k1 into a is equal to k2 into a of tan of k2 into a you are going to get. This is the equation number 1 you have to write. What is this? This is the equation number 1. k1a is equal to k2 into a tan of k2 into a you able to take that is the equation number 1. Now antisymmetric bound state solutions you have to write it is the similar fashion. What is the your wave function? Psi1 is equal to a e to the power of k1x, psi2 is equal to c sin k2x, this is the antisymmetric wave function. Psi3 is equal to g e to the power of minus k1x, these are the wave functions for antisymmetric states. So these are the wave functions, the set of wave functions for antisymmetric bound state. Now you have to apply the boundary condition. You have to apply the boundary condition at x is equal to a you have to apply. So boundary conditions you have to apply. Boundary conditions you able to apply boundary conditions. Where we have to apply the boundary conditions? At x is equal to a. At x is equal to plus a you have to take you are to apply. So for a bound state boundary condition 1 by psi2 into dou psi2 is divided by dou x at x is equal to a, which is equal to 1 by psi3 into dou psi3 is divided by dou x at x is equal to a. This is the bound state boundary condition. Which boundary condition? The bound state boundary condition. From this boundary condition you have to apply 1 by psi2 is equal to 1 by c into sin k2 into x or k2 into a. Directly I substituted. You have to differentiate k2 into cos k2 into a into which one we are getting, that is the c. Directly I am substituting that one. Here you able to take it as a k2. Clear? Right. So now 1 by psi3 is equal to 1 by g e to the power of minus k1 into x. Again you have to differentiate k1 into a, you have to substitute here g into e to the power of minus k1 into a into minus k1 we are writing. So g into e to the power of minus k1a, c get cancelled. Therefore we are going to get it k2 into cos k2a is divided by sin k2a, cos k2a is divided by sin k2a is equal to minus k1. So therefore k2 into cot k2a, which one it is? Cot k2a is equal to minus k1. Cot k2a is equal to minus k1. Now again you have to multiply on both sides a term. So k2a into cot k2a is equal to minus k1a. This is the equation number 2 you have to write it is. This is the equation number 2. So what is your equation number 2? Minus k1a. So we have to write it is minus k1a is equal to, so what is that? Minus k1a is equal to, you able to get that one. Now you have to you able to take the k1 square a plus k2 square a, you have to apply k1 square a and k2 square a, you able to calculate how much you are going to get once you able to see here. So first we need to calculate the k1a whole square, k1a whole square plus k2a whole square we need to calculate. How much you able to get? So k1 square is equal to, you know that 2m into v minus e is divided by h cut square. This is the k1 square. K2 is equal to, you know that, so what is that k2 value? 2m is divided by h cut square. This is the k2 value. Now a square you have to take the common here. So how much you able to get? 2m by h cut square also you have to take the common. You able to get v minus e plus we able to consider as a e you are going to write. So plus e minus e get cancel. How much you are going to get? A square into 2m v is divided by h cut square.
So this is the value. So this value, how much you are going to get? K1A whole square plus K2A whole square, K1A whole square plus K2A whole square is equal to 2m into V A square is divided by h cut square. This is, you have to take it as a r square, that is the radius of that size of the size of the potential well or bound state, that bound state you have to consider. So therefore, how much you able to get it here? So from this r is equal to, or radius is equal to, what we have to write, that r is equal to square root of 2mv a square is divided by h cut square. 2mv a square is divided by h cut square. So this is the, so that potential well or bound state is depending upon the radius, depending upon the potential, depending upon the width of that material also is depends. So therefore, from that what we have to write it is r square is equal to 2mv a square is divided by h cut square. From this equation we have to write it is the deeper means V is very large and broader. So the broader means A is very large, the broader the well. So the larger value of, if it is deeper is large, the broader A. So what is going to happen? Your R also is very more. The larger value of the R, it will give the greater number of bound states. How many bound states it will give? The larger number of bound states is going to give. So this is very important conclusion you have to remember. So how we have to explain this? The deeper and broader value of the well, that is the bound state system, that is the well. So the larger value of R it will come. Therefore, if it is larger value of R, so what is going to happen? Greater number of bound states can happen. So from this, how we have to apply this condition, how we have to apply, once you have to take, here you able to draw the curves, the number of points of intersects in the graphs, you have to take the graphs. Here two curves are there. First you able to take what is very important curve is there. This curve is very important. So you have to take this curve. So the in x axis you able to take it as a k1a. In x axis you have to write it is k1a, you have to take x axis. In y axis you able to consider as a k2a, you have to draw that y axis. Suppose you able to take it is a 0, this one you have to write it as a 0. Now after some time you able to take it as a 5/2. So after some time you have to write it as a 5 you have to take, and after some time you able to take the odd the value. So 3 5/2. So and after some time you have to consider as a 2 5 and so on is there. Clear? So you able to consider. First you able to draw the curve. What are the your equations are there? K1a and K2a equations are there. K1a is equal to K2a into tan K2a. So K1a is equal to, what is your first equation? So apply the first boundary condition, you are going to get the first equation. K1a is equal to K2a tan K2a. K1a is equal to, based on the symmetric boundary condition, we are going to get it. So based on the symmetric boundary condition, K1a is equal to, we are going to get, so that this is the value we are going to get. So which curve is it is? K1a is equal to K2a tan K2a, you are going to get it. This is a symmetrical one we have to write. Now the corresponding to that, so what is going to happen? This is the 5/2. This region is 5/2 region you have to take. So which region you able to consider? This region you able to take it as a 5/2 region. Now you have to write it as a 5/2. What is going to happen once you able to take? So you have to write it is, we are going to write, so this value you able to take next equation, anti-symmetric equation, you are going to get it. So what is that anti-symmetric equation? Minus K1a is equal to K2a into cot K2A minus K1A is equal to K2A into cot K2A, you are going to get it. So therefore, so what will happen, you have to see here, so you able to take here, so phi you have to consider again, so continuous line you able to get here, so this is the symmetric value. So what is this, K1A is equal to, so K2A tan K2A, K1A is equal to K2A and tan K2A. Again, so 3 by 2 you have to take 3 by 2. So what is going to happen? So again is the dotted lines it will come. So that dotted line you able to take here. So what is going to happen here? So this is minus K1A is equal to K2A into cot K2A, you are going to get it. So therefore again you have to do here. So what is going to happen once you able to see, again there is a continuous line it will come. So again there is a continuous line, so and so on it will be prolonged like this. So K1A is equal to K2A tan K2A, you are going to get it, and again so it will be prolonged like this. So now from this diagram, how we have to observe one thing you able to see, here I wrote the number of point intersects in the graph, the number of point intersects in the graph, whether it may be continuous lines or dashes lines, will give us number of bound states. So what is this? The number of points intersects in the graph. Suppose based on the radius you have to intercept, suppose n is equal to 1, you able to take the first radius, you are going to write it. This is the r square value. What we have to write it is r square is equal to r value have to take. So what is going to happen? This is the radius of that curve you are able to take. This is the radius. So this radius, based on this radius, how many intersect points are there? Only one intersect point is there. This is the intersect point. Clear? Now you have to consider here one more line you able to take here. So once you able to write it is one more line from based on, so 0 to 5 by 2, here 5 by 2 in between 5 you have to take. How many intercepts are there? This is the first intercept, this one is the second intercept. Now you have to take 5 by 5 to 3 5 by 2. Now you have to draw the line, so 5 to 3 by 2. Here one intercept, there is one more intercept and one more intercept is there. Here now you have to consider, what you have to consider here, so you able to 3 5 by 2 2 5. So you have to take here one intercept, so here you have to write it as one intercept, so one intercept and one more intercept, you able to take it as you have to write it is here one more intercept, you able to get it. Clear? So now you have to write it is a continuous line, so you have to take it is one more intercept you able to consider. Clear? So this is which one you have to write it is based on that you able to take it as a K2A tan K2A. Now based on this diagram we able to see, we able to observe. So what we are going to observe once you have to see here, based on this diagram you able to see here the dotteds are there, you have to take you able to consider is a continuous line, you able to take it is a dot 1, you have to take continuous line, you able to take it as a dots. So you able to consider as a dots, you able to consider on the continuous line. Now you on the continuous line you have to take it as a dots, you have to consider. This is the dots. In the continuous line, dots you able to take here also continuous line, it is a dash line only, no. So this dash line only you have to take it as a, so cross one you are able to take. Now you have to observe this dot, you able to take it as a symmetric number of states. This dot is indicated that symmetric bound state. So this dot you have to indicate it as a symmetric bound state you have to take. This dot you able to consider as a symmetric bound state you have to take, dash dot. So it cross you have to take it as which one you have to write it is anti-symmetric bound state you able to consider. Which one it is the anti-symmetric bound state? So that anti-symmetric bound state is cross you have to take it as the anti-symmetric bound state. from the diagram you able to see, first we have to observe the symmetric bound states. We have to observe how we have to observe the symmetric bound state. Once you able to see, we need to observe a symmetric bound state. We have to observe, clear, how we have to observe the symmetrical bound state. First we have to take it as a symmetrical bound state. I am observing symmetrical bound states. Which one I am observing? Symmetrical bound states I am going to observe. What are the symmetrical bound states? Once you are able to see, in the symmetrical bound states, once you are able to take where we are observing, our radius is 0 is less than or is less than 5 by 2. Our 0 is less than or is less than 5 by 2. Our symmetrical bound states is equal to. So, how many symmetrical bound states are there? The symmetrical bound states is equal to, how many symmetrical bound states are there in the continuous line? So, in the only one bound state is there. This is only one, clear. So, that is why we have to write it is only one intercept is there, that is the only one bound state for what is that? So, 0 is less than r is less than 5 by 2. If our radius is 5 by 2 is less than r, your radius is 5 by 2 is less than r is less than 5, you able to consider how many symmetrical bound states are existing. How many symmetrical bound states are existing once you have to see. So, first in between 5 by 2 to 5, 5 by 2 to 5. So, the line you have to consider here. So, here one dotted line is there on the continuous line, one dashes is there. So, this dotted line indicated, this intercept indicates. So, this is the symmetrical bound state. This one is the another anti-symmetrical bound state. So, therefore, how many is there? 1. That symmetrical bound state is equal to only 1. So, in between 5 by 2 to 5. The similarly you have to take here. So, 5 by 2 to 3 5 by 2, 5 by 2 3 5 by 2 you have to see. So, your line is, so what is your line? Here how many bound states are there? The symmetrical bound states and the continuous line 2 and dotted line 1 is there, that is the anti-symmetric one. Now, you have to write it is, so if you able to take 5 is less than or is less than 3 5 by 2, your symmetrical bound states 5 is less than or is less than 3 5 by 2, your symmetrical bound states is equal to, how many symmetrical bound states are there? 2 symmetrical bound states are there, clear. Now, you have to take here, so one more thing you have to 3 5 by 2 to 2 5 by, how many symmetrical bound states are there? This is 1 and this is 2 symmetrical bound states are there. So, therefore, you have to write here, so what is going to take once you have to write it is, so your 3 5 by 2, your radius is in between 3 5 by 2 is less than 5 2 5. So, 3 5 by 2 r is less than 2 5. Your symmetrical bound states is equal to, how many symmetrical bound state is existing? Only 2 symmetrical bound states are existing. So, this is the case we have to discuss till now. Now, you able to take it is for anti-symmetric bound states I am taking. Anti-symmetric, which one we have to write? For anti-symmetric bound states I am applying, for anti-symmetric bound states you able to see for anti-symmetric bound states. How we are going to apply that for anti-symmetric bound states you have to take here. For a anti-symmetric bound states, once you able to observe for anti-symmetric bound states, so you have to see here, so for anti-0, so you able to take 0 is less than or is less than 5 by 2. If 0 is less than or is less than 5 by 2, for anti-symmetric bound state, anti-symmetric, so anti-symmetric bound states, what are the anti-symmetric bound states? Is there any anti-symmetric line is there for 0 to 5 by 2? There is no anti-symmetric boundary condition. So, there is no anti-symmetric line. So, that is why, so there is no cross, this is take it as a 0. So, for anti-symmetric bound state. Similarly, you have to observe 5 by 2 is less than or is less than 5. So, in between 5 by 2 or is less than 5, how many anti-symmetric bound states are there? So, how many anti-symmetric bound states are there? Only one anti-symmetric bound state is there. That one you have to write it is that anti-symmetric bound states is equal to how many? 1 is there. Anti-symmetric bound state is equal. So similarly you have to take our radius is phi is less than r is less than 3 phi by 2. You have to write it is our radius is phi is less than r is less than 3 phi by 2. How many anti-symmetric bound states are existing? So how many anti-symmetric bound states, that anti-symmetric bound states phi is less than 3 phi by 2. Here also you have to take only one anti-symmetric bound state is there. How many? One anti-symmetric bound state is there. So therefore in the lastly you have to take so 3 phi by 2 is less than r is less than 2 phi. You have to observe your radius is in between the 3 phi by 2 to 2 phi. How many anti-symmetric bound states are existing? So that anti-symmetric bound states is equal to how many anti-symmetric bound states are existing? Here one anti-symmetric bound state and here one more anti-symmetric bound state is there. So total how many? So total 2 anti-symmetric bound states are existing. So therefore we have to write it is anti-symmetric bound states are 2 anti-symmetric bound states are there. So based on this you have to take for symmetric bound state for the same region it is 1, it is 0 anti-symmetric bound state. Here equal also existing, here 2 is 1, here 2 is 2. So therefore what we have to write based on these results, maybe symmetric bound state is greater or equal also can exist. So therefore what we have to write here, so one note I have to make to you. So this note is very important note I am making. So what is that note? The number of symmetric bound states. So therefore what we have to write it is the number of symmetric bound states, the number of symmetric bound states, the number of symmetric bound states is greater than, so greater than or equal to, the number of symmetric bound states is greater than or equal to the number of anti-symmetric bound states, anti-symmetric, the number of symmetric bound states is greater than or equal to the number of anti-symmetric bound states. What are those bound states you are able to consider as the number of anti-symmetric bound states? Suppose I am example I am giving, suppose you have to take the example you able to see, right. So how many number of symmetric bound states and anti-symmetric bound states are existing? Suppose the total number of bound states is equal to 4. Suppose you have to take here the total number of bound states, the total number of bound states is equal to, the total number of bound states is equal to 4. If it is 4, what will happen? The symmetric bound states can exist 2 and anti-symmetric bound states can exist 2, because 2 can exist only, the total number of bound states is 4. So if you have to take, if you have to consider as a, if the total number of bound states is 5, the total number of bound states you able to take it as a 5 total number of bound states are existing, then what is going to happen? Exactly half you have to do, 2 plus 2. So now one more rest of the thing is that rest you have to take it as a symmetric bound state is equal to 3 and anti-symmetric bound state, anti-symmetric bound state is equal to how many? So that is the 2. So we have to write it is a symmetric bound state and anti-symmetric bound state you able to consider like this. Clear? So like this you have to do in your competitive examination. So they will test you, they will tilt you. So you unable to what we have to write it is what we call it as unable to confuse. So you have to do this one. So the number of symmetric bound states is greater than or equal to, the number of symmetrical bound state is greater than or equal to the number of anti-symmetric bound state. This is very important thing you able to consider. Now we need to draw a general formula. So we have to derive the general formula. What is the general formula for the bound states? So how we are able to define the general formula for the bound state? Once you able to take, here we have to consider, which one we have to consider? It is a bound state you able to take. So now what is this? At x is equal to minus a boundary, at x is equal to plus a. What is the width of this boundary? So, the width of this bound state is equal to 2a width is there, clear. Now, we able to know, suppose our radius is you able to take our 5 is less than r is less than 3 5 by 2, let you have to take our radius is in between the 5 and 3 5 by 2. So, you have to square on both sides, 5 square is less than r square is less than 9 5 square is divided by 4. So, but you know that your r is equal to, so r is equal to 2m E is divided by h cut square, 2m into v is divided by h cut, your r is equal to 2m into v is divided root 2m into v is divided by h cut square into a. So, this is your r value. So, your r is equal to, so root 2m v is divided by h cut square into a, this is the r value. So, that r square value have to substitute. So, therefore, what is going to happen, you able to see 5 square is less than r square is less than 9 5 square is divided by 4. So, r square value how to substitute 5 square, your r square is equal to 2mv is divided by h cut square into a square is less than 9 5 square is divided by 4. Now, the potential you have to keep inside. So, the rest of the thing you able to take outside. Here what is going to happen, 5 square h cut square is divided by 2m into a square is less than v is less than, you have to write it as 9 5 square h cut square is divided by, we able to take it as this one you have to write it is 4 into 2 8m a square we are writing. So, 8m a square we able to take. So, this one we need to write it is, so what is going to take, once you able to take, so how we have to rearrange this thing, how we able to rearrange, once again you have to take 5 square h cut square is divided by 5 square h cut square is divided by 2m a square is less than v is less than 9. So, we have to take 5 square h cut square is divided by 8m a square, but your a is equal to, what is your a? Your a is not 0 to a, your a you have to take it as a 2a. Your length of the potential well is equal to 2a, your length of the well is equal to 2a. So, therefore, instead of a you have to substitute the 2a. So, what is going to happen, you able to see, instead of a you have to substitute 2a. So, you able to get it as a 0 point energy you have to going to get. So, that how much energy you are going to get it, once you have to see here. So, let that 2a you have to write it is 5 square h cut square is divided by, so 2m into, so 2a is equal to, what we are going to write it is, you able to take 2a whole square is less than v is less than 9 5 square h cut square is divided by 8m into, here we have to write it is, we need to take here. So, what is going to happen, not here. So, we are observing, so 2a we are observing, you have to see a square you are able to take. So, 4 is divided by 4 you have to write it is, here also 8m a square it will come. Now, you able to take here 4 5 square h cut square is divided by 8m a square, 2m a into, so this is 2a whole square is less than v is less than 9 is divided by 5 square h cut square is divided by 2m into, we have to write it is a, which one we are able to take, so 2a whole square we have to write it is. So, therefore, what we are going to write, we are defining one energy, that energy is a 0 point energy we have to write it is. So, what is the 0 point energy? ZPE, ZPE 0 point energy, 0 point energy we have to write it is, ZPE means 0 point energy. If let n is equal to 1, that is the ground state of the potential well, n is equal to 1, what is the En value, that energy value you have to take it as n is equal to 5 square h cut square is divided by 2m a square, a is equal to 2a whole square, that is phi square h cut square is divided by 8 m a square. This is the 0 point energy when n is equal to 1. That energy we call it as a ZPE. ZP is equal to phi square h cut square is divided by 8 m a square. This phi square h cut square is divided by 8 m a square. We call it as a ZPE. ZPE. So therefore you have to take here. So this is which one? Phi square h cut square is divided by 8 m a square. This one also phi square h cut square is divided by 8 m a square. So based on this, what we have to write here? So 4 into ZPE, 4 into ZPE is less than V is less than 9 into ZPE. 4 into ZPE is less than E is less than into 9 into ZPE. This one we have to write it is 2 square into ZPE is less than V is less than 3 square into ZPE I am writing. So therefore if you have to take the total number of states, this one it will give the total number of states. What are total number of states in the bound state? The total number of states where n is equal to total number of states. So therefore if n is equal to, you have to write it is n is equal to 3. So it is 3 minus 1 it will come. So this 3 is the total number of states. That's why what we have to write, the general formula n minus 1 whole square into ZPE is less than potential energy is less than n square into ZPE. We have to write it is, this formula is very important formula. N minus 1 whole square into ZPE is less than V is less than into n square into ZPE. What is your n? Your n is a number of total number of bound states. What are your? So what is that? Total number of bound states. So this n is where n you have to take it as a n is equal to total number of bound states you have to consider as a, this is your n. Your n is the total number of bound states. Clear? So now you are able to take here what is going to happen. So one more general formula I am giving to you. So the general formula for the bound states, the first formula I derived. So what is that first formula? N minus 1 whole square into ZPE is less than V is less than n square into ZPE. What is your n? N is the total number of bound states. This is a first formula you have to write it is, where n is equal to total number of bound states. Total number of bound states. So your n is going to take it as a total number of bound states. This is very important. Now the second formula I am giving. Suppose if you have to consider for a electron, you able to see once you have to take a for electron. So for electron and n is equal to 1 you have to consider. If n is equal to 1 you able to take. So what if you have to consider the width of the well is equal to L, you able to say. So what is your formula? Your formula ZPE you have to write it is ZPE is equal to, so ZPE is equal to n square phi square h cut square. Phi square h cut square is divided by 2m into L square, which is equal to n square by L square into 38 electron volt. How much you are getting? 38 electron volt you are getting. This is the another formula for the ZPE. This one also you have to use. ZPE is equal to n square by L square into 38 electron volt for, so what it is for the 38 electron volt for electron. If you have to take the electron mass, you able to consider, you able to get it. Clear? Now we will see the problems. How we able to get the problems? You have to see 2-3 problems we able to take. An electron moves in one dimensional box of width is equal to 8 angstroms. So that one electron is moving. Suppose you have to take it as a one dimensional box of width is equal to 0 to a, you have to consider how many angstroms? That 8 angstroms. That box width is equal to 8 angstroms. So that box depth is equal to how many angstroms is there? 12 electron volt is there, we need to calculate the number of bound states we need to calculate. So, for calculating the number of bound state, first we need to calculate how we have to calculate here. First ZPE we need to calculate. So, what is your ZPE? 0 point energy. Your 0 point energy is equal to, so what is your formula for the 0 point energy is equal to phi square h cut square is divided by phi square h cut square is divided by 2m a square. This is your 0 point energy. Phi square h cut square is divided by 2m a square. But you know that, so what we have to 9, so pi square h cut square is divided by 2m a square, this is your 0 point energy. But you know that, so this is a electron is moves in one dimensional box. So therefore what we have to write it is, so we able to take that already we are giving, now only I am giving n square by x square. N square by x square means 1 square by L square, 1 square by L square, that is L is equal to or x or whatever it may be, 1 square by L square into this A you have to consider as a L you have to take, otherwise you able to take it as a L. This one you have to consider as a L you have to take. So what you are able to consider, L you have to consider here. Phi square h cut square is divided by 2m L square is equal to 1 square is divided by L square into 38. For ground state I am writing 38 electron volt. N is equal to 1 because it is a one dimensional box. N is equal to 1, that N is equal to 1 is nothing but a ground state we have to write it is. A ground state you able to take 38 electron volt you have to write it is. So 8 angstrom is there, that's why you able to take it as 8 square, the 64 you have to get it. So 38 by 64, so 38 by 64 this is the electron volt. 38 by 64 electron volt is equal to 0.6 electron volt you are going to get. So which is equal to ZPE is equal. Now you have to write it as ZPE is equal to 0.6 electron volts. Now what is the boundary? So what we need to calculate? The number of bound states, N is equal to how much? The number of bound states we need to calculate. What is our formula? So to find the number of bound states is equal to n minus whole square into ZPE. N minus whole square into ZPE is less than V is less than n square into ZPE. N minus whole square into ZPE is less than n square into ZPE we need to write it is. So now you have to take it as a n minus whole square into ZPE. So we have to write it as n square into ZPE we able to take. Here you have to consider, so ZPE is equal to, we need to know ZPE is equal to 0.6 electron volt. This is the ZPE value. Now n square is less than, V is equal to 12 electron volt. So is less than, ZPE is equal to 0.6 electron volts into n minus 1 whole square. N minus 1 we need to take it as a n minus 1 whole square we have to write it is. First n is equal to, suppose if you have to consider n is equal to, let you have to take n is equal to 4 you have to write it is 4 square, 4 4 ja 16 it will come. So 4 4 ja 16, so 4 square minus 1 square it is 9 it will come. So 9 is the lesser value of the 12, correct. So 9 is a lesser value of the 12, the 4 square is equal to, we have to write it is 16, 16 into 0.6, 16 into 0.6 it will come that, so 12 is greater value able to get it. So 12 is less than that, so not getting, so that's why you have to take phi square you able to get it. Phi square here you have to take it as a 4 square it will come. So therefore the total number of states 25 into 0.6 electron volt, 25 into 0.6 electron volt, 16 into 0.6 electron volt. So in between the, so 12 electron volt it will come. So 12 electron volt. So therefore our total number of bound states is equal to, how many total number of bound states are there? the total number of bound states is equal to how many? 5 total number of bound states are there. So, like that you have to do in your competitive examination. Total number of bound states is equal to how many total number of bound states? 5 total number of bound states are there. If it is 5 number of bound states you have to consider. So, what is going to happen? Otherwise you able to take here 0.4 also you able to correct, 4 also, 16 also, in between 9 and 16 4 also existing. So, therefore, you have to write it is 4 number of bound states you able to take, clear. So, you have to consider as a 4 number of bound states. So, therefore, you have to write it is you multiply and you once you check it. So, the total number of bound states is equal to total number of bound state is equal to total number of bound states is equal to how many total number of bound states? 4. If it is even number, so the symmetric bound states is equal to symmetric bound states is equal to 2, anti-symmetric bound states is equal to how many? So, 2 anti-symmetric bound states it will come. If it is 5, symmetric bound state is 1 greater. So, that is 3 anti-symmetric bound state is equal to 2, you able to get it, clear. So, like this you have to do in your competitive examination. Now, one more question you have to see here. Consider a particle of mass m in a one dimensional potential well, which is the consider a particle of mass m in a one dimensional potential well. This is the one dimensional potential well, right, of which a 2a depth 2a well of width is equal to 2a. You have to write it is that width is 2a, this one width you have to take. So, width you have to consider, this is not width. So, the width is 2a and the depth of the potential is you have to write it is v is equal to, they are giving minus a plus a, this is the width you have to take it as a 2a. So, the depth is equal to how much? 5 square h cut square is divided by m a square. So, find the number of bound states we need to calculate. How we have to calculate the number of bound states you have to see. So, for calculating a number of bound states, what is going to happen once you have to take it is, so here you able to take, so first you have to observe ZPE, you able to observe 0 point energy you need to calculate, that ZPE is equal to n square 5 square h cut square is divided by 2m l square or a square you have to take. So, now you able to consider n is equal to 1, that is the ZPE, the ground state energy is divided by 5 h cut square, 5 square h cut square 2m into a square is equal to 2a whole square. So, therefore, what you are going to get 5 square h cut square is divided by 8m a square, this is the ZPE for corresponding to that problem. 5 square h cut square is divided by 8m a square. But you know that, so for finding the bound states, what is the general formula? N minus 1 whole square into ZPE is less than V is less than n square into ZPE. This is the general formula we are writing. N minus 1 into whole square into ZPE is less than V is less than n square into ZPE we need to write. So, you have to substitute here. So, what is going to happen you able to see here. So, you able to take, so this one you have to write it is your potential is equal to, what is your potential? Here you have to take your potential 5 square h cut square is divided by m a square is there, this is your potential. 5 square h cut square is divided by m a square. Now, you have to write it is your potential, how much potential is there you able to take here. You have to write it is your ZPE is equal to, you have to write so how much the width is there, 2a width you able to take, right. So, what is going to happen you able to take here you have to multiply with 8 and divided with 8. So, V is equal to 8 into ZPE we have to write it is, V is equal to 8 into ZPE. Now, you have to substitute here n minus 1 whole square into ZPE is less than 8 is less than n square is there. So where it is coming, how it will come, n square is less than 8 you are able to take. Suppose you able to take n is equal to 3 you have to consider. So that is the 9, obviously is less than 8 is less than the 9. You have to write it is here. So n minus 1 whole square, 3 minus 1 whole square is equal to 4. You have to take it as a 2 square is equal to 4. So that's 4 also is less than. So your 8 is 4 is less than 8 is less than 9. So therefore what is your n? Your n is equal to 3. Number of bound states is equal to. So this is the number of bound states. How many bound states are there? 3 number of bound states are existing. So if it is 3 number of bound states, the symmetric bound states is equal to 2. The anti-symmetric bound states is equal to, how many anti-symmetric bound states can exist? So the anti-symmetric bound states is equal to 1 number of anti-symmetric bound state is existing. Like this you have to do in your competitive examination. So not only that, one more question I will give to you. So there are only 3 bound states for a particle of mass m in one dimensional potential well of the form as shown in the figure. So now you have to take here, so in the potential well, so you have to consider as a box is there, minus a by 2, you have to take it as a plus a by 2, minus a by 2 plus a by 2. So what is the width? You have to take it as a width only. You are able to take it as a V naught is there, this is the x axis you are able to consider. The depth of the potential well is satisfied. So how it is satisfied once you able to find out. So there are only 3 bound states are existing. Only 3 bound states are existing for a particle of mass m in one dimensional potential well of the form as shown in the figure. How we have to define once you able to see. What is our formula? General formula is equal to n minus 1 whole square into ZPE is less than V is less than n square into ZPE. This is the general formula for the bound states. So general formula for the bound state. So what is the ZPE? For ZPE 0 point energy is equal to, so for a one dimensional box, so n is equal to 1 you have to take. So that ZPE is equal to 5 square h cut square is divided by 2m a square. This is the ZPE corresponding to that problem. Now how many number of states is existing? 3 number of bound states are existing. So therefore what we have to write it is less than V is less than 3 square into ZPE. So that ZPE is equal to 5 square h cut square is divided by 2m into a square. So now we have to write it is n minus 1 whole square means 2 square into ZPE. So that ZPE is equal to 5 square h cut square is divided by 2m a square. This is the ZPE you have to write it is. So therefore you have to simplify, you able to get it. How much you are going to get? 4 square means 1 2 get cancelled. Here nothing is cancelled. So therefore 2 5 square h cut square is divided by m a square. So 5 square h cut square is divided by m a square is less than V is less than what we have to write it is 9 5 square h cut square is divided by, so 2m a square. So this is your condition to obtain the how many bound states? 3 number of bound states is existing. So like this you have to do your competitive examination. Clear? So many times your competitive people are asking the question based on this. So one question is I am left behind, maybe how to teach after some time this one in the YouTube channel I have to teach to you. You have to solve this and try to solve. A particle in one dimension is the potential they are giving. A particle is one dimensional in the potential, how they are giving once you have to see. So V of x is equal to infinite when x is less than 0. V of x is equal to infinite when x is less than 0, correct? So later you have to take so minus V naught is there when 0 to L, when x is equal to L, clear? So now you have to extrapolate like this, when x is greater than a, so V of x is equal to what we are going to take it as a 0 you able to take. This is the region 1, this one is the region 2, this one is the region 3. Now we have to write it is So there is at least one bound state. At least one bound state means how you able to get 0 to 5 by 2, in between 0 to 5 by 2 at least one bound state is existing. If there is at least one bound state, the minimum depth of the potential, V is equal to how much they are asking, that V is equal to h cut square phi square is divided by 8 m L square, you are going to get it. So this is the minimum depth of the potential well. So you have to try to solve this one. How you able to get it is minimum depth of the potential well. How we are getting once, you have to see here. So at least one bound state means that is the 5 by 2. So the 5 by 2 is equal to what we have to write, that is the r square. So r is equal to 2m v naught, that is the v. So L square is divided by 2m v naught, L square is divided by all to the power of 1 by 2. If you have to simplify, you able to get the v value. V is equal to phi square h cut square is divided by 8m L square, you are going to get. This is very, very important one. Like this you have to do in your competitive examination. Clear? So please practice. Today is enough, and tomorrow I have to take some another important, suppose not only this well in the one dimensional box, if it is a spherical well, what is going to happen, we will see and enjoy. So thank you so much. Be practice. Today is enough for you. Thank you.